Picture this. You swallow what's marketed as a heart-healthy 400 IU capsule of vitamin E before bed, confident you're protecting your cells from oxidative stress. Yet by the time you wake, the biochemical landscape inside your brain has shifted in ways most people, and even many clinicians, never suspect. Within hours, high-dose tocopherol begins thinning blood vessel walls. In a very real sense, you've primed the cerebral plumbing for leakage. A landmark meta-analysis covering nearly 119,000 participants showed that supplementation with vitamin E elevated the risk of hemorrhagic EN stroke by roughly 22%, while offering no meaningful protection against the far more common ischemic variety PMCNE, BNF, GO. Why does this matter? Stroke isn't just an acute medical crisis. It's the leading neurological cause of long-term disability worldwide. Minutes of disrupted blood flow can erase decades of memories, dull emotional nuance, and paralyze the very circuits that let you hold a loved one's hand. From a behavioral science standpoint, anything capable of shifting stroke probability overnight demands our attention, because a single subtle supplement habit could undermine every other lifestyle investment you make in cognition, fitness, and emotional resilience. Today, we'll unpack the hidden neurovascular dynamics behind high-dose vitamin E, explore how dosage, timing, and individual biology interact, and most crucially, outline safer protocols you can adopt immediately. Along the way, we'll translate dense biochemistry into plain language tools, simple blood work benchmarks, evidence-based alternative antioxidants, and behavioral levers like meal timing and sleep depth that reinforce vessel integrity instead of eroding it. Here's the roadmap. The dose response trap, why more antioxidant isn't always better. Clotting versus cognition, how vitamin E modulates platelet chemistry and microbleeds. Genetic wildcard, the APOE and VCORC1 variants that amplify risk. Dietary context, whole food tocopherols via isolated megadoses. Circadian chemistry, why taking fat-soluble vitamins at night may magnify vascular stress. Safer paths forward, targeted micronutrients, and behavioral habits that protect brain vessels without collateral damage. By the end, you'll not only understand the science, you'll leave with a concrete protocol to safeguard your brain tonight. Because knowledge is potential, but applied knowledge is power. We've all been taught to believe that antioxidants are good. They neutralize free radicals, reduce inflammation, and slow aging. At least that's the common narrative. But here's what most people never learn. Antioxidants follow a principle known in neuroscience and pharmacology as the biphasic dose response. Simply put, more isn't always better. In fact, beyond a certain threshold, the same substance that once protected your cells can begin to cause subtle yet significant damage. Vitamin E is a perfect example of this paradox. Most vitamin E supplements contain alpha-tocopherol, one of 8 forms found in nature. At low doses, typically below 150 IU per day, alpha-tocopherol can indeed protect lipid membranes from oxidative stress, especially in high exertion individuals like athletes or those recovering from illness. But once doses creep beyond 200 to 400 IU daily, particularly when isolated from its siblings, tocopherols and tocotrienols, a tipping point is reached. A 2005 meta-analysis published in Annals of Internal Medicine analyzed data from 19 clinical trials and found a consistent trend. High-dose vitamin E supplementation greater than equals 400 IU per day was associated with increased all-cause mortality. While the reasons remain debated, the vascular effects of excess alpha-tocopherol appear to be part of the story. What's happening in your brain when this occurs is both subtle and profound. At high concentrations, alpha tocopherol can disrupt the homeostasis of other fat-soluble antioxidants, such as gamma tocopherol and vitamin K, both of which play critical roles in regulating inflammation and clotting within the brain's fragile microvasculature. Think of this like a symphony. One instrument playing too loudly drowns out the others, throwing off the entire performance. In this analogy, vitamin E taken in excess starts to overpower the balance that keeps your blood vessels responsive, resilient, and sealed. Here's what the research shows. Vitamin E can inhibit platelet aggregation, the ability of blood cells to clump together and form clots when needed. While that may sound helpful for preventing ischemic stroke, where clots block arteries, it becomes dangerous when it impairs your body's ability to stop bleeding in the brain. That's where the risk of hemorrhagic stroke comes in. Now, you might be asking, should I stop all vitamin E supplementation entirely? Not necessarily. The key is understanding context and dose. If your diet is low in vitamin E-rich whole foods like sunflower seeds, almonds, and spinach, you may benefit from a small supplemental amount. But consistently taking large, isolated doses, especially late at night when your body's clotting factors are naturally downregulated, can tip the scale from benefit to harm. A simple tool to apply is this. Aim for food-first antioxidant intake. Get your tocopherols from a variety of nuts, seeds, and leafy greens. If you're supplementing, cap your intake around 100 to 150 IU per day, unless advised otherwise by a qualified medical provider. And if you're taking blood thinners like warfarin or aspirin, be especially cautious because the interaction between vitamin E and anticoagulants can quietly amplify bleeding risk. The deeper lesson here is behavioral. More of a good thing doesn't mean better outcomes, especially when it comes to brain health. Like with many supplements, the dosage determines the direction of the effect, protective or harmful. So next time you reach for that high-dose vitamin E capsule, thinking you're giving your brain an antioxidant edge, ask yourself, is this calibrated to support my biology, or is it disrupting a balance I don't fully understand yet? Coming up next, we'll explore what happens inside your blood vessels and brain when this balance tips, how vitamin E affects clotting factors, cerebral microbleeds, and long-term cognitive performance. And if this insight is helping you rethink your supplement stack, consider subscribing, because this channel is dedicated to unpacking these subtle but powerful shifts that can change your brain, body, and life. Let's zoom in on what's actually happening inside your bloodstream, and more importantly, inside the vessels that supply your brain. Every moment of your life, your brain is using around 20% of your body's oxygen supply. That oxygen is delivered through an intricate web of arteries and capillaries, some so small they're just wide enough for red blood cells to pass single file. Now, imagine one of these tiny vessels begins to leak. This is not just a metaphor. It's a real risk when the body's clotting system is disrupted. The brain is highly vascularized, but has no room for swelling or bleeding. A leak here isn't like a bruised muscle. It's like a short circuit in your most delicate high-speed hardware. So where does vitamin E come in? Alpha tocopherol, again, the form most commonly found in supplements, has been shown to interfere with the aggregation of platelets. Platelets are your body's first responders when it comes to stopping bleeding. They form the initial plug at a site of injury, followed by a cascade of clotting factors to seal the damage. This process is exquisitely balanced. Too much clotting and you risk stroke from blockage, ischemic stroke. Too little and you risk bleeding, hemorrhagic. Here's the twist. Studies have found that high levels of alpha tocopherol inhibit key enzymes involved in the platelet activation process. It's a bit like sending firefighters to a blaze, but disconnecting their hoses. The crew is there, but they can't stop the fire. A pivotal trial, the Physicians' Health Study 2, explored this over a decade with over 14,000 male physicians. It found that vitamin E supplementation did not reduce the overall risk of major cardiovascular events, but was linked to a significant increase in hemorrhagic stroke. What this tells us is that even among health-conscious, educated individuals, the intended benefit of supplementation can backfire silently and fatally. Now, let's relate this to cognitive performance. Microbleeds in the brain, tiny ruptures of small vessels, don't always produce immediate dramatic symptoms, but over time they accumulate. Imaging studies in older adults show that a higher number of cerebral microbleeds is correlated with declines in executive function, processing speed, and memory. And one of the contributing factors? Antiplatelet activity from medications or supplements taken over long periods. Have you noticed brain fog after starting a new supplement routine, or unexplained dips in attention or mood regulation? It's worth asking whether your vascular health is quietly shifting. This isn't just about risk of stroke. It's about the subtle erosion of the brain's structural integrity over time. Here's what you can do. First, if you're taking a supplement that affects blood viscosity, whether it's vitamin E, fish oil, aspirin, or turmeric, you need to be mindful of stacking effects. Combining multiple blood-thinning compounds increases risk multiplicatively, not just additively. Second, request a blood panel that includes coagulation markers like PT prothrombin time, INR international normalized ratio, and platelet count if you're regularly using these supplements. These simple lab tests can reveal early shifts in clotting balance long before symptoms arise. Third, assess your cognitive baseline. Use simple tracking tools like journaling your focus levels, reaction time apps, or even informal memory tests. Subtle declines over weeks or months might be the first signal that something deeper is occurring in your neurovascular system. If this is helping you rethink how supplements interact with your brain, not just your body, make sure you're subscribed, because on this channel we take a holistic approach to brain health. Not just performance today, but protection for the decades to come. Now we'll explore how your genetics could be silently amplifying your risk, how common gene variants like ApoE and VK-ORC1 can turn an ordinary supplement into something far more dangerous. Most people don't know they carry these genes, but the consequences can be profound. Imagine two people, both in their 50s, both taking the same vitamin E supplement, 400 IU daily. One experiences no side effects, maybe even some benefits. The other quietly develops microvascular fragility, increasing the risk of hemorrhagic stroke by 30% or more over time. What's the difference? Genetics. And your genetic makeup shapes how your body processes nutrients, regulates clotting, repairs blood vessels, and responds to oxidative stress. Two gene variants, in particular APO-AOR and VK-ORC1, have been shown to significantly influence how your body handles vitamin E and related processes. Understanding these genes is like having a user manual for your vascular system. Let's start with ApoE, or apolipoprotein E. ApoE plays a key role in lipid transport and brain repair. There are three common forms: ApoE2, ApoE3, and ApoE4. If you carry one or two copies of the ApoE4 allele, your body metabolizes cholesterol and fat-soluble vitamins differently and less efficiently. That includes vitamin E. But the concern doesn't stop at metabolism. ApoE4 is also associated with a weakened blood-to-brain barrier, an increased susceptibility to inflammation. This means that when high-dose vitamin E interferes with clotting or antioxidant balance, the effects can be magnified in ApoE4 carriers. The fragile capillaries in your brain become more prone to leaking. especially under conditions of oxidative stress or disrupted circadian repair. Now, let's talk about VKORK1, the gene responsible for encoding the vitamin K epoxide reductase complex subunit 1. This enzyme is critical for recycling vitamin K, another fat-soluble nutrient that's essential for blood clotting and vessel integrity. Some people carry a common VKORC1 polymorphism that makes them overly sensitive to vitamin K antagonists like warfarin. Here's the kicker. Vitamin E at high doses can act as a mild antagonist of vitamin K activity. So if you carry this variant and you take large doses of vitamin E, your clotting ability may be impaired without you ever realizing it until the day your brain is pushed over the threshold. It's a dangerous synergy. Impaired recycling of vitamin K combined with excess alpha tocopherol creates a subtle chronic thinning of the blood. For those with this genotype, even standard doses of vitamin E 300 to 400 IU daily could elevate stroke risk over time, particularly when other blood thinning supplements or medications are present. So how do you know if you carry these variants? While genetic testing isn't yet standard protocol in most clinics, it's becoming more accessible through consumer services. If you've done a DNA test through a health service or ancestry platform, you may already have this data available. Search for your APOE status and VKORC1 polymorphisms. If you find you carry the APOE4 allele or are a VKORC1 variant carrier, it's not cause for panic, but it is a call to be more intentional with your supplement choices. Here's a simple tool to implement. If you haven't tested your genetics, operate under the precautionary principle. Assume you might be sensitive and avoid megadoses of fat-soluble vitamins unless prescribed. Focus instead on dietary sources, lower-dose multivitamins, and functional foods that deliver antioxidants in their full-spectrum, bioavailable forms. If you have tested and you carry one of these variants, consider working with a practitioner to tailor your nutrient protocols. You may need to avoid standalone vitamin E altogether and prioritize nutrients that reinforce vessel repair, like magnesium, omega-3s, and vitamin K2 in carefully monitored doses. Remember this, our genes don't determine destiny, but they do inform design. When we understand our biological blueprint, we can adapt our behavior to work with, not against, our body's natural chemistry. Now we're going to explore the dietary dimension of this conversation, how food-based tocopherols differ dramatically from synthetic isolated vitamin E supplements, and why your salad could protect your brain more effectively than your capsule. Let's take a step back from capsules and bottles for a moment and turn our attention to something far more ancient, food. Before we had supplement aisles and megadoses in soft gels, vitamin E was something we consumed as part of a complex nutritional matrix found in nuts, seeds, greens, and oils. And here's the critical insight. The form, balance, and biological impact of vitamin E in food is fundamentally different from what you get in high-dose synthetic supplements. To understand why, we need to look at vitamin E not as a single compound, but as a family of 8 structurally related molecules, 4 tocopherols and 4 tocotrienols. The alpha tocopherol found in most supplements is just one member of this group, and when taken in isolation, especially at high doses, it can actually displace the other forms in your tissues. That displacement is where part of the problem begins. What's happening in your brain and body when you consume vitamin E from whole foods is far more balanced. For example, gamma-tocopherol, abundant in walnuts and sesame seeds, has unique anti-inflammatory properties and has been shown to complement alpha-tocopherol by neutralizing reactive nitrogen species, something alpha-tocopherol can't do. Tocotrienols, found in foods like palm oil, barley, and rice bran, have been studied for their neuroprotective effects, including reducing lipid peroxidation in brain tissue and supporting healthy white matter integrity. And here's the key difference. In whole foods, these compounds arrive together in ratios and structures your body has evolved to handle over thousands of years. The antioxidant effect is synergistic, not dominant. There's a built-in buffering system that reduces the risk of any one form becoming excessive or disruptive. Now compare that to a 400 IU dose of isolated alpha-tocopherol taken before bed, especially without any gamma-tocopherol or tocotrienols present in your diet. Not only does this flood your system with one unbalanced form, it actively lowers the tissue concentrations of the other forms. That's right, high-dose alpha-tocopherol can push down the levels of gamma-tocopherol in your blood and tissues, potentially stripping away key anti-inflammatory defenses that your brain relies on. Here's what the research shows. People with higher whole food intake of mixed tocopherols, especially from raw nuts, seeds, and leafy greens, tend to have better cognitive outcomes as they age, lower markers of oxidative stress, and healthier lipid profiles, not because they're flooding their bodies with one molecule, but because they're supporting a diverse network of protective nutrients working in harmony. A simple tool to apply here is what I call the 5x5 antioxidant rule. Aim to eat 5 servings of vitamin E to rich foods 5 days a week. That could look like a handful of almonds or sunflower seeds.